All right, team, it is time to try solving some multi-step equations. It's going to be a little heavy lifting, if you know what I mean. So these examples are taken from your workbook. And so I'm just going to show you how I would work through them. And you guys may have some similar strategies. You might have different strategies. All of these problems that I've picked are a little bit different. So you may want to come back to this video, or at least the last page of it, if you need to kind of keep an example close up in front of you as you work on solving multi-stepped equations. So in class, we did a little bit of a practice on this on the whiteboards that we were using. So that was a nice way to get started. And remember that each time in each of these problems, eventually what we want to do is we want to isolate this value that is the variable. So in this particular problem, we're going to get the a value by itself. And because it's attached to this term, I'm going to leave this term alone for just a second. So this term right here, it's going to stay put, this plus 5a. And I'm going to work on balancing my equation, keeping my equation balanced, and getting rid of this negative 10, okay? So remember, we have opposite operations that undo each other. So the opposite of a minus 10 is going to be a plus 10 on both sides. What's left on one side of the equation is my 5a equals, and a negative 55 combined with a plus 10 means I'm actually starting at negative 55 on my number line, right? I'm at negative 55 way down here. I'm actually adding 10, so I'm actually going up the number line. Okay, so that's going to take me up to a negative 45. And then this step you guys are getting really, really good at. Dividing by 5, opposite of multiplying right here. And because it is a negative value divided by a positive value, we're going to get a is equal to a negative 9. And so there is your first example. All right, let's move on very quickly here and get through these 4 examples. So this is a nice short little video for you guys to watch. All right, again, we're trying to get this n by itself. So we're going to leave the numerator alone for a second. This number 10 is not helpful right here, but we'll just kind of ignore it. And because you see a divided by 3, what we're going to do is we're going to multiply both of our sides by 3. Now, I know you guys wanted to go ahead and distribute that through your numerator. I'm going to encourage you not to do that at this point. This is like 3 divided by 3, and then your 9 plus n is what's left. Please don't forget that when you have 3 divided by 3, that value is actually 1. So it's 1 times 9 plus n, which still equals 9 plus n. And then the last step for this particular problem will be to subtract 9 from both sides. And what does that leave us with? It leaves us with n is equal to, and we're subtracting, we're not dividing. So remember, because it's tied with addition, we're subtracting that positive 9 from both sides. So what is that? 27, take away 9. Hopefully you guys are thinking in your heads what that could be. And we're all done. Okay, so those were a couple of good examples of 2-step equations. Let's move on and try this type of problem where you have n values on one side and n values on the other, integers on both sides as well. And what we want to try and do is we want to get kind of the n's on one side, the integers on the other, so that we can actually continue to solve. All right, here is your example. I'm going to go ahead and I'm going to move this minus 6n. I'm going to add 6n plus 6n. I'm going to go ahead and put my line here at my equals so I can tell I'm keeping my equation balanced. You may not want to use that strategy. That's just one that I'm offering to you to use. It's possible just to, keep your equation balanced and use an equal sign, but sometimes that helps us to see our sides of the equation. Over here, -5 plus 6 is 1n plus 8 equals 6. 6 drops down. I'm going to subtract 8 from both sides of my equation, again, making sure it's balanced. Those will cancel, and I will be left with 6 plus a -8, or 6 minus 8, which is a -2. Okay. I'm going to move this up just enough so we have enough room to work in case you want to pause the video here to be able to see some of these examples when you're doing your homework. Okay, guys? This one, oh my gosh, this one is crazy. There are so many different variables in this one. Okay, so let's take a minute and I'm just going to use my highlighter and I'm going to highlight wherever I see the terms with an m in it. So there's a -2m, and there's a +5m. That's on one side of my equation. Here's a +8m and a -m. That's on the other side of my equation. So sometimes if I'm combining like terms, I will color code those terms that are going to be combined on either side of our equation. So now we can sort of get after this. The 14 is an integer by itself on this side of the equation. -2 plus 5. What's that going to be? 3? That looks pretty good. Now, my -6, I could put it first here or I could put it at the end. I'm going to hold off for a minute and combine my 8m with a -1. 8 combined with a -1. That's going to be 7m. It's sort of like 8 mangoes minus 1 mango is 7 mangoes, kind of like that. If you need to assign your m value something that you can kind of think about subtracting and adding. My -6 is still there. I'm going to go ahead and add 6 to both sides. Let's go ahead and do that. It really doesn't matter. You might not have gone this route first. Maybe you decided to subtract 3m from both sides and move things that way. Totally okay to do it either way. 14 plus 6, it's going to be 20 plus 3m. All right, now I don't want to move my 7m, right? Remember, I want m's on one side, integers on the other. So I'm going to go ahead and subtract my 3m from both sides. We get 20 is equal to 4m. And the last step, let's see if I can keep this all together here for you, is to divide by 4. Okay? And you have your answer. It's kind of skirting off the bottom of my screen. All right, there are some examples for you guys on solving multi-stepped equations. All right, good luck today and good luck this week on this work. Please let me know if you have any questions, and we will just keep practicing these guys because they do take a lot of practice. So persevere and keep up the good work.